All right, just as when we were little kids, we're going to learn about adding and subtracting fractions. Now, adding and subtracting fractions, we know, is a little bit more difficult than multiplying and dividing fractions. So let's get a quick review of adding and subtracting fractions. Things like a third of a cup of sugar plus a third of a cup of sugar. Now, if I ask everybody to answer that, go ahead and just take a second and what do you think the answer would be? So I've heard many answers over the years, what a third of a cup of sugar plus a third of a cup of sugar is. But the actual answer is 2/3 of a cup of sugar. We do not add the bottom number together. Some of us probably said a third of a cup of sugar plus a third of a cup of sugar was 2/6 of a cup of sugar, which reduces to a third of a cup of sugar. That does not make any sense at all, that I have a third of a cup of sugar plus a third of a cup of sugar equals a third of a cup of sugar. So it's important to note that when you have a common denominator in adding and subtracting fractions, that you do not add the denominator. Leave the denominator the same. Complex fractions are things like 2/3 over 4. Fractions within fractions. Okay? And the simplest way to explain how to do that is if I take the bottom number and make it a fraction, 2/3 divided by 4 over 1, or 2/3 times 1 over 4 would get me to that. So that's a complex fraction. All right, let's take a look. Add, subtract with like numbers. Subtracting is really just adding negatives. So when we talk about this, we're really going to talk about adding mostly. To add or subtract rational expressions with like denominators, simply add or subtract their numerators. All right. Then place the result over the common denominator. So if I said a over c plus b over c, you would say that's a plus b all over c. And if I subtracted them, you'd say that's a minus b all over c. That makes sense. So in example 1, if I said 9 plus 2, hopefully we would all say that's 11 over 6x. All right. When we're adding, or subtracting fractions with unlike denominators, the first thing we have to do is find the LCD, the least common denominator, which ends up being the least common multiple. I guess I should have said, you guys can write least common multiple of the denominators. So what number does each of those two numbers go into? All right, so the letters aren't going to make much sense to us, or they might, but I'll go through them anyways. If I have a over c plus b over d, I can't add those things unless I multiply the left one by d over d. Now d divided by d is just 1, so I'm just changing what it looks like to make it ad over cd. And I multiply the right one by c over c to make it bc over cd. Now I have cd, like terms on the bottom, so on top I have ad plus bc. And it's the same thing for this next one, just ends up being ad minus bc, sorry, all over cd. A whole heck of a lot more sense to us. This will make more sense to us when we're actually doing this with numbers. And so when I look at something like this gnarly looking thing, this is a mess right here, I have to find a least common denominator and move from there. So to find the LCD, factor each denominator. So you want to factor it right out if I can. So I'm going to do 5 over, and I'm going to call that 2x, and that's what all my factors. And the other one I'm going to call x plus 1 over, looks like 2x goes into both of those things, 2x, and then it ends up being x plus 2 as the other factor there. Okay, so if I factor that whole thing out, 4x squared was 2x and x, and the other one was 2x and x plus 2. So the least common denominator of that thing would be you don't duplicate the parts and pieces, I guess is the best way to put it. So this one over here already has a 2x. It has two of them, in fact. So we say that's a 2x and a 2x. And the one over here has a 2x and an x plus 2, so I don't want to repeat that. So if I have 2x, 2x, and x plus 2, those would be all the parts for each one of these. Therefore, when I'm making a common denominator, I want to get to that. I want to get to 2x, 2x, and x plus 2. Now, if I take the one on the left, if I take this one, I'm going to multiply it by x plus 2 over x plus 2, which is just 1, so I'm not changing the value, I'm just changing what it looks like. And the other one, which is 2x times x plus 2, it doesn't have the second 2x, so I'm going to multiply it by 2x, top and bottom. So, when I put all of that stuff together, see, this is 4x squared times x plus 2, whoop whoop, which is 4x cubed plus 8x squared. So when I multiply that together, my common denominator ends up being 4x cubed plus 8x squared on both of them. 4x cubed plus 8x squared. Hopefully you're listening, not just writing, because I'm sure right now you're thinking, what the heck is he writing? Then I multiply whoop whoop, and I get 5x plus 10, whoop whoop, 2x squared plus 2x. And now that I have a common denominator on the bottom of 4x cubed plus 8x squared, the top is combined like terms. 2x squared, 5x plus 2x, 7x plus 10. Now that's a pretty tough problem, but that's a pretty good answer. All right, let's take a look at example 3 now. Now, in example 3, common denominators, what I would do is factor each of these out and see what I have. On the left-hand side, it looks like I have 3 times x minus 3. So 7 over 3 times x minus 3. On the right-hand side, it looks like I have x plus 4 over difference of squares, x minus 3, x plus 3. Okay? So it looks like the one on the left needs an x plus 3, and the one on the right needs a 3. So I'm going to multiply each of those things by the one on the left, x plus 3 over x plus 3. So that ends up being 3x minus 9 times x plus 3. The one on the right ends up being x squared minus 9 times 3, which gives me a common denominator. If I multiply all those things together, 3x squared minus 27. Okay, so that's what my end answer is going to have. Now, on the top, I have 7x plus 21. And I have 3x plus 12. Now, here's where people make a mistake. Make sure you put parentheses around that, so that when it says minus here, you're doing 7x minus 3x, which is 4x, and 2 minus 12, which is negative 10. A lot of people will answer plus 14 on that one, and that's where they'll go wrong and get a wrong answer. 6 there. On page 226, you have 4 little things to do. Go ahead and check out for a minute and do the checkpoint. All right, welcome back. Hopefully on that first one, you got 8x minus 7 over 3 plus x. Had a common denominator, made it really easy. Hopefully on number 2, you got 15 over 3x, but then you reduced it, because we learned about that in the last section, and made it 5 over x. Now, on the next one, a little more difficult, looks like it's x plus 3 times x plus 3 on the left, and on the right it's x plus 3 times x minus 3. So I need an x minus 3 on the left, and I need an x plus 3 on the right. So I'm going to take this one right here and multiply it by x plus 3, top and bottom. Okay? And the other one I'm going to multiply by an x minus 3, top and bottom. All right? And after I did all that work, all the foiling, and if I did everything correctly, I would end up with x squared plus 4x plus 15 over x plus 3 squared times x minus 3, if you want to do it that way, or x plus 3 times x plus 3 times x minus 3. Okay, something like that. And number 4, if you notice that this is a 4x squared here, the other one has what goes into 8 that also goes into 12? 4. What else? 4x. So number 4 there has a 4x that's going to come out of it on the right hand side. So if I have a 4x that comes out of it, I'm left with a 2x and a minus 3. Now the left hand side has a 4x, but it has an extra x. See how that has a 4x and an x? So the right hand side is going to need an x. The left hand side is going to need a 2x minus 3. So when I do all that work, I have 8 times 2x minus 3 is going to be my top number, and the other one is we're going to multiply the top and the bottom by x. And so as I finished that whole thing up, if I just kind of went down that path, and hopefully you ended up with this, negative x squared plus 14x. And remember, if you didn't end up with this, you can always ask tomorrow in class. That's what the class is for. Minus 24 over, and what I would do is just this right here. Ends up being 4x squared times 2x minus 3. Sorry for that. Handwriting looks a little shaky there. All right. Simplify complex fractions. I think I already kind of talked about that. So I want to move right into example 4 and open this up a little bit and just start working right away on it. When we're looking at simplifying complex fractions like this, there's a lot to it, but we need to understand that fractions just mean division, essentially. So first thing I'm going to do is simplify the denominator if I can on this one, because it looks pretty tough. But once I put that together, x plus 1, they have a common denominator already, so it ends up being x plus 5 over 15. Okay? And if it's 8 over 5x, really divided by x plus 5 over 15, then as we talked about in that one section, you're just flipping this and making it 15 over x plus 5. And now, pretty simple, you're just top times top, bottom times bottom. 8 times 15 is 120. Bottom times the bottom here is 5x squared plus 25x. So that makes that whole thing pretty easy. As we're looking at this last page here, this one, obviously, this is a much tougher problem to tackle. So we have a lot of work to do. And the first thing you want to do is clean up the bottom and make it one fraction. That's probably the best way to go in my book, I would think. So as I look at the bottom, I would say if this is 1 over 3x, I'm going to multiply the top and the bottom by x plus 1. And when I look at the other bottom, I'm going to multiply the top and the bottom by 3x. Okay? And if I multiply all that out, I have x plus 1 plus 6x over my common denominator here, which is going to be 3x times x plus 1. I'm going to leave it separate for right now. I think that x plus 1 up here is giving me a little hint that I might be able to delete it later. So I end up with 7x plus 1 on the bottom of the bottom. Okay, so if I have 7x plus 1 over 3x times x plus 1, and that's what my entire bottom ends up being, well, then it just simply ends up being 2x over x plus 1 it was going to be divided by this thing, but now instead of being divided by it, it's going to be times its reciprocal, 3x times x plus 1, and as I said before, that x plus 1 looks like it's going to eliminate, over 7x plus 1. The x plus 1's go away. 3x times 2x is 6x squared over 7x plus 1. There's a lot of ways to do that. You go ahead and try that next one. You guys try the number 5 and number 6. And I'm just going to shoot you the answers on those real quick. Let's see if you get here. 5x over 16 plus 6x. Can you get from here to there? And on the other one, can you get to 5x plus 14 all over 6 minus x? Don't forget, you know, on this first one, you have common denominators, so you have right away 5x over 4 divided by 3x plus 8 over 2. Then you just flip it, and you're going to have to then find some more common denominators from there. That ends up being, you know, pretty tough problem. And on this other one, this one right here, this is the granddaddy of them all. Looks like there's a ton of work to do, although it looks like because we have these common things on the bottom here that there might be some shortcuts in the middle there once you find those first common denominators. So good luck with that. Make sure you reduce all the way. And those, I would be expecting somebody's going to ask those questions tomorrow.